Assalamualaikum and good morning to all of you. So we are going to discuss about our separation unit in our integrated project, which is the production of propylene glycol. And I am Siti Zulaika bin Khalid, and my other teams, which is Wong Widong, we representing our group, will discuss about this topic. And this slide is prepared by our two other teammates, which is Lee Jun Seong and Tan Kian Long. So we go to our next slide. The separation and mechanism. In our process plan, separation process is carried out to obtain high purity of propylene glycol. So to achieve this, we need 3 distillation column that involve, and then we choose the distillation column number 2. We choose to do our calculation. So this is a briefly introduction about our separation and the mechanism that we use, which is distillation column. Next, we go to our next slide, which is the distillation column. The multi-components in the feed stream of distillation column T102, and the heating mechanism and separation of component through volatility difference. High volatility will be vaporized, low volatility leave the distillation column through the liquid state. So for the multi-component feed, as at the distillation column 2, the process separation that occur is at the feed there will be 3 substance, which is ethylene glycol, propylene glycol, and unreacted glycerol. So the feed, the substance will be separate by the ethylene glycol and propylene glycol will be distilled out at the top of the distillation column, while the unreacted glycerol will be distilled at the bottom as the liquid phase. So how the separation is occur? So we can see about the point number 3, the high volatility will be vaporized, the low volatility leave the distillation column through the liquid state. From the from the high volatility will be vaporized. So from the volatility, we can make the volatility depends on the boiling point, which is for the unreacted glycerol, the boiling point is 290 Celsius. For the ethylene glycol, the boiling point is 197 Celsius. For the propylene glycol, is the boiling point 188.22 Celsius. While from the distillation column reaction temperature will be 229.8 Celsius. So how we want to create the relationship between the volatility and the boiling point. So the lower the boiling point, the higher the volatility. As we know, the temperature at the distillation column will be 229.8. So at this temperature, the ethylene glycol and propylene glycol will be in the gas state. They will vaporize to become the gas state. So that's why they will be distilled at the top bottom as the gas as the gas state, and the bottom will be the unreacted glycerol, as the boiling point unreacted glycerol is 290 Celsius, right? So which is higher than the reaction temperature, so they will not vaporize, it will become the liquid state and distillate at the bottom. That is how we separate the unreacted glycerol with the other substance, which is ethylene glycol and the propylene glycol at the distillation column number 2. So our next point is glycerol is heavy key component and ethylene glycol is a light key component. How we want to determine which one is the heavy key and which one is the light key, right? So the heavy key we always have the least volatility. Least volatility means a higher boiling point. That's how we make the relationship between that 3 parts. As we know, the least volatility in this reaction is unreacted glycerol. So unreacted glycerol will become the heavy key, and ethylene glycol and propylene glycol will become the light key. So to make the calculation much easier, we choose the ethylene glycol as our light key. That is how process separation happen in the distillation column number 2.
Shortcut method, Fenke's underhood method, or known as FUG method, is used to calculate the required parameter value in distillation column T102 because the phi to T102 is multiple components. Fenke equation is used to calculate minimum number of equilibrium stage and mean and distribution of non-key components, which correspond to total reflux. There are several assumptions of this method. First, the process is in steady state and no heat losses between the reboiler and condenser. Second, there is no further feed in feed stream and no withdrawal of product in outlet stream. Third, the relative volatility of the component are constant throughout the distillation column, and the mixture forms an ideal solution. From the formula where D and B are distillate and bottom respectively, I is light key component, J is heavy key component, and A mean is mean relative volatility. Relative volatility at the top and bottom stage are calculated by using the K value of each component in T102. Finally, we calculate N mean. The value is 2.9614, which is around 3 stages. Next, the underhood equation is applied to calculate the minimum reflux ratio, R mean value. First, we use underhood equation to obtain the delta parameter value. Since only glycerol is in liquid stage in the feed stream, the Q value is 0.1153. The delta calculated is 0.1836. We proceed our calculation using second underhood equation with delta obtained before. Finally, we get R mean is 0.2367. Assume R equal to 2 R mean, therefore reflux ratio R is 0.4734. Linear correlation is applied to determine number of stages, and after performing the calculation on my right hand side, the number of stages N are 6.85, which is approximate to 7. The trade efficiency is then calculated by using equation N mean over N times 100%. Hence, the trade efficiency in T102 is 42%. Stiff tray with diameter of perforation of 1/8 inch to 1/2 inch is selected in distillation column T102. Stiff trays are used because of its low cost as compared with other type of tray. This stiff tray is shown as figure on my right hand side. The column diameter is calculated using the formula on my right hand side, and we get 0.3748 meter. Since the compute column diameter dt is 0.374 meter, which is smaller than 1.524 meter. Packed column is more suitable to use as separation unit in this separation process. The column height LT is calculated as the formula LT equal to HOG times NOG. HOG is defined as heat of transfer unit HTU based on overall gas phase mass transfer coefficient, while NOG is defined as the number of transfer unit NTU based on overall gas phase mass transfer coefficient. Therefore, the column height LT is 1.2126 meter for T102. Thank you for watching this video.